And what we're after is I want to implement this. Okay, and the thing is that because we're because of this point 2D stuff and because of this implicit state, there are just some things that we need to, that I need to just kind of do. So let's, I'm going to put this in a separate package called, well, I'll call it mover. And, okay, I'm going to call it the simplest mover because it is literally the simplest one. And as its name indicates, we're going to have more complicated ones coming up. But again, the idea is to start as simple as possible. And this is about as simple as we can get, but we can actually do some interesting things with this, as we will see. So first, to define an event graph model, what are the steps? So the first step is to subclass symmetry base. And then we'll fix that import. Okay, make sure that all red squigglies are gone. Next, parameters. So we have the initial location, which is a vector, and then the constant speed. So those are going to be private instance variables. And the type is going to be point 2D, as I said. So, and I'll call it the initial location. And just as a comment, that's going to be our x of I. Okay, we got a red squiggly. We'll fix the imports, and let's see what it's Java AWT geom point 2D. That's the this Java AWT geom is a package that it actually has a lot of pretty.
Sir, are you demoing on NetBeans?
Yes, you can't see that?
No.
Oh, crap. Okay, well, let me undo. I thought I was sharing the whole thing, but I was not. So let me start all over. All right, sorry. Okay, so let's try this again here. Let's create our package. Again, I'm going to call it mover. And create a new Java class. I'm calling it the simplest mover. And okay, when we define an event graph model, the first thing is when we're implementing it, after we've defined it, the first thing is to extend symmetry base. And red squiggly, fix the imports. Okay, fine. Now, our parameters, private instance variables with setters and getters. Now, the thing with something, remember with object states or even object parameters, we just as we had with arrays as parameters, we need to make sure that we're not breaking encapsulation. So we'll see what that's about. But remember that we're going to use Java's point 2D class to represent locations and velocity. So I'm going to call it initial location. That's going to be what I'm calling x of I. xi for initial, red squiggly, fix imports. And again, here's the Java AWT geom. Point 2D is in that package. It's a very useful package for doing graphics and other things, but it turns out that point 2D is the useful thing there. So the other state is, just to emphasize, I'm going to call it the max speed. I think I called it speed in the in the event graph. I'm going to call it max speed just to emphasize that we're always just going to be going full bore. Now, what I like to do next is, and this is just sort of a refactor idiosyncrasy. For some reason, it needs at least one thing there in order to do the refactoring properly. So again, I want to encapsulate my fields, and I want setters and getters for everything that are private. And so I want to have it after my 0 argument constructor. Okay, so the scalars, like primitives, like doubles, there's no problem. But see here, this could potentially break encapsulation. And this is where I need to, just like with arrays, I want to return a clone of this, but then the way that clone was implemented, it was implemented as a, it returned an object, so I need to cast it to a point 2D. And likewise, when I set it, I also need to set a clone and cast it to a point 2D as well. Again, so why fuss about this? The fussing is because without the copy, I'm breaking encapsulation. So somebody else is going to get a direct reference to my instance variable here, which is a key thing. And if they change if they get that reference and they change what they've done, then they will screw up what I've done, what I have here. So that, again, that's this encapsulation that I keep ranting about is a critical element of all this. Now, just one little thing, and I won't do it here just yet in the interest of time. Well, no, maybe I should. Is that if I give it a max speed that's less than 0, then that's what does it mean to have a maximum speed less than 0? That has no meaning. Now, I might give it a maximum speed of 0. In other words, if I want to have one of these things that is syntactically like a mover but can't move, then I might want to give it a max speed of 0. So, but if not, but I certainly can't give it a -1. So I want to throw an illegal argument exception and say basically that max speed must be bigger than or equal to 0. But you give me this. Okay, so that's that. And then now, as is our wont, we have our master constructor, which will consist of our parameters. And as I think I've mentioned, okay, oftentimes it's useful to just call this, even though we're not doing anything yet, we might in a little bit. Why? Because sometimes when you have object states, we need to instantiate them somewhere. And if I can instantiate it at the 0 argument constructor, that's actually the preferred place. In some cases, I can't, like with the transfer line, it turned out I couldn't, but that's sort of another thing. So the convention is to then call the setters. And this is important for max speed, because if I don't call the setter, then I'm opening the possibility of a bad value getting in. Now, at this point, again, the way I recommend doing this, and in fact, I'll put it right in here just so. I'm just sort of I'm going to be testing it out. And so I want to write a main method where I am confirming that the parameters have actually gotten in. So to that end, so I need to figure out how can I do this? How can I instantiate this? So, I can't, turns out, remember I said that point2D is as abstract, and that's exactly what it's saying. Point2D is abstract, cannot be instantiated. So I have to say point2D double. And notice that it has a 0 argument constructor. And if I call that, then it initializes it with coordinates 0 and 0. I don't want that. I'll put it at 30 and 40. And let's make our max speed 25, say. Okay, what are these units? They're not really specified, but they need to be consistent. That's so if my coordinates are in kilometers, then my speed needs to be in kilometers per unit time. If my times are in hours, then it needs to be in kilometers per hour. If my coordinates are in miles, then my speed needs to be in miles per hour. So, but we're leaving it unspecified. It doesn't really matter. Okay, all I'm doing is I'm just, before moving on, I'm confirming that my parameters have gotten in. That's all I'm doing. And what I'm looking for is I'm looking to see whether or not my initial location and my maximum speed have gotten in, and I see that they have. Now, notice that the toString for point2D tells you exactly what it is with the coordinates. So that's fairly useful. What can be a little bit noisy is the fact that it has this point2D double stuff in there always, but we can deal with that. Okay, so I've implemented the parameters, and now I need to implement the state variables. So what are my state variables? I have the last stop location, the time that the move was begun, the current velocity, and the current destination. So let's do these. So these are going to be protected. I'll call it last stop location. And that was what we were calling X0. The destination, that's what we were calling D. Now, velocity, remember, velocity is a vector. And that's what we were calling V. And then finally, the time, I'll call it start move time. That's what we're calling T sub naught. Okay, so now the first thing I want to do is I want to encapsulate those. Again, I don't want the setters. I want it to be protected. And let's make it the last method. And before I move forward, I want to, again, for the getters for this, I want to always return the clone. Oops. Okay, now I see I've fat-fingered velocity. Now, I think I've shown you this before, but I can, if I refactor and rename it, I can change it everywhere. Okay, notice it changes the point2D. Start move time is a, okay, this Okay, what happened? I'm missing one. For some reason, it didn't give me this one. Let's make it the last method. Again, so all the, whenever we're setting these through the methods, we want to clone it. Now, the thing about states is that we, unlike the parameters, we need to actually start working with them. So we need to initialize them. And we initialize those in the reset method. And so we initialize T naught to 0, X naught to the initial location, velocity to that, and the destination to not a point. So what we need is we need to have our state, these three state variables. I want to keep reusing the same object on that. And so what I need to do is, well, I don't need to do it, but what I am going to do is in my 0 argument constructor, I'm actually going to instantiate those. So starting with the last stop location, I'm going to give it a double with a not a number and not a number coordinates. That's what we're sort of conceptually calling not a point. And oops, what happened? And then, oops. And finally, our velocity. Okay, so the point here is that we are, oops, that one, all right. Okay, so now they've all been instantiated, and so our reset method, which you always call super first, our reset method can now initialize things. So our last stop location, remember I said it has a thing called set location, and our set location, we can get the initial location. Our destination, now even though we've kind of done it here, we're going to do it again. And then finally, we'll set location to 0 for the velocity. Okay, so now we have a velocity of 0, and our do run method will simply fire the property changes. So for start move time,
Arnie, when you get a second after you do that, can you go back up to your constructors real quick? What is one shoot on?
okay, so remember I called this, so what I'm doing is I'm instantiating these 0.2D objects so that as they change their coordinates, I can simply set those. The thing is, I need to instantiate them somewhere. And so see in reset, I'm setting the location. If I haven't instantiated them by then, I will have gotten a null pointer exception. So I'm just instantiating them in my 0 argument constructor. Does that make sense?
Yes.
Okay. And now, again, everything we've done is pretty much in play here. So last stop location. And we have our destination. And this is just confirming that we are initializing things correctly. Oops. And so once we've instantiated it, what we can do is now we can use our simple property dumper. And I'm going to put it true for reasons that we'll see in just a little bit. And so now I'm our simple add property change listener, our simple property dumper. I'm going to set verbose to be true. I'm going to reset. And start simulation. Okay, so what am I looking for? I'm now looking for I'm looking for the run to be firing my initial values. So here's the run. Here's the start move time, last stop location. Okay, notice that's set to the right thing. My destination is not a number coordinates because I don't have a destination yet. And my velocity is 0. Okay, so check. All right, now, see the way that I advocate implementing these is to go one event at a time. So let's start with the move to event. And all the move to event says set the I have an argument, which is the destination, and I set the destination to its coordinates. Is what I want. So I say public void do move to, and my argument is a point2d destination. Now, or let's just say new destination, just to make it a little different. Okay, and what its state transition is, okay, now it says our destination is equal to the argument, but again, I don't want to do that. I want to do, well, let's do our old destination is going to be our get destination. Now our destination are going to set the location to the new destination and fire a property change for destination, the old destination, get destination. Okay, so here's the conundrum, is that I need to schedule that somehow. And then notice that run is not scheduling that, and I don't want run to schedule that because I want this to be scheduled by some other component, which we will have to get to tomorrow. But so how can I at least test this? Well, here's a way I can test this. If I look at between reset and start simulation, and this is just a placeholder, I can actually implement a wait delay on this. Okay, so I'll tell you what, let's I can give it a delay, and then here's my destination. Let's send it to the origin. Okay. Again, this is a just to okay, this is we're just testing. Okay, what I'm looking for is I'm looking to see whether or not this move to thing is going to happen. And is it going to happen at the right time? So I'm saying wait 1.5 time units and then say move to. So here's our move to. Again, so run, here's run. Run didn't schedule this. This was sort of scheduled elsewhere. But here's the move to. And we see that the destination now goes from not a number as coordinates to the one that I sent. Okay, so there's a check. Okay, so now for the this is the this is the hard one now. Okay, so here's the start move. I need to compute the velocity, the sim time, and the time to travel. Now, if you notice one thing, that this d minus x naught norm divided by s is actually in this velocity here as 1 over that. In other words, s over d minus x naught is actually 1 over this move time. So in implementation, it actually would be helpful or convenient to do that first. Okay, so here's my start move event. I'll call it move time is going to be what? Well, what do I need to do? I need it's the norm of that difference divided by the time. Okay, so so let's just to do this computation, the difference, I'll call it the delta, is and what is it going to be? It's going to be the destination minus the last stop location, x, and the y. Okay, this don't know what the heck that was. Let's get y minus the last stop location, get x. Okay, so that's my delta. That's the d minus whatever. And so my move time is going to be now the let's see, was it the, oh, I'm sorry, actually I don't need to do all this. I can use the I'll call it the distance, and that is the last stop location, the distance to the destination. And so my move time is simply the distance over the maximum speed. Okay, you see that here, distance over the maximum speed. Now the Oh. For the start move time, I need to do the oops, I need to fix my imports on that and get the sim time. So my start move time is what time is it now? I'm going to fire the property change for start move time. Right, what is the, okay, now finally I need to do the velocity. So the velocity is going to be that difference, and now I can't avoid that anymore, divided by the move time. So let's see what that looks like. So can I get the old one? And since I'm getting a copy, everything is fine. So well, let's okay, what is the X value? The X value is going to be the destination. How does it do that? The destination get X minus the last stop location, get X. And that's going to be divided by the move time. And then Y is going to be the same thing, but with the Y coordinate. And okay, so now I can set my, oops, velocity, set, I can set location now with the X and the Y. And finally fire the property change. So that, not the index one, the regular one. Oh, and move to should have scheduled start move, so I'd better do that. And then finally, I'm going to schedule my end move with the move time. And now when I run it, okay, so let's see here. Now our move to event, again, our destination. Now at time 1.5, our start move time is 1.5. Our velocity is now what this is. And am I missing something? I am, well, no, those are the only two states. This move time was not a state variable. I could have made it a state variable, but the only reason for it is for this delay. So it's actually not, it's just a local variable. And I could have just put that up there, but basically, I see that the end move event is happening 2 time units after my start move. So that's a check. And finally, my end move is going to, again, set my current location to the coordinates of my destination, velocity to 0, and I'm going to say I don't have a destination anymore. Okay, so Yeah, notice that end move event occurred here because I scheduled it, but there was nothing to happen. So I need to put something there. Okay, so now what is there? I need the get last stop location. My last stop location, I'm going to set the location of the destination and fire the property change. Okay, that's the one. Next, my velocity is 0. Again, I do that by setting location to 0, 0, and fire the property change. And then finally, I set my destination to not a point. And not strictly speaking, totally necessary. I need to make sure I do that after I set the last stop location. Okay, so now what has happened is in just looking at things, again, my run initializes everything correctly. My move to says now my destination is the origin. That schedules us a start move with a 0 delay. My start move time is now the current time. The velocity now becomes this value, schedules an end move. The end move occurs, and now my last stop location is equal to the old destination. My velocity now becomes 0, and my destination is now has not a number of coordinates. Okay, so basically, with the exception of commenting, which I will do before I push it, I can now say something like, you know, I've implemented this simplest mover. Okay, but now we say, okay, well, that's you may be thinking, all right, that we can get from one place to the next, okay, but what if we want something, you know, typically it's going to be a little bit more complicated than that. So the idea now is, again, think iterative development here. So I have a component that can get from one place to the next as long as I schedule that move to event. So the idea is to have, if I want more complex movement, I can build that up using that same component. And in other words, build a sequence of simple maneuvers based on some kind of rule. And that thing that is something I call a mover manager. So the idea is that a mover manager component, it's going to direct a single mover instance according to what its rule is. And there are actually many that we could develop, but really the simplest 3 are the ones we're going to focus on here. The first is going to be what I call a path mover manager. And what it does is it consists of a sequence, a list of waypoints. And again, it's directing one mover, just one mover manager, one mover. And it's going to direct it to a list of waypoints. And it's going to say, go here. And when you're there, go here, etc. And it's going to visit each one in sequence, and it's going to stop at the end. Now, there are two more that we don't have time for today, but we will get to in successive classes. One is called I call a patrol mover manager, because unlike with the path mover manager, I say, okay, here are the waypoints, go there and then stop. Patrol, if you think of when you're patrolling, you kind of keep going over the same locations again and again. At least that's one way to do it. So it's basically the same as a path mover manager, but then at the end, instead of stopping, you start again at the first waypoint. So in other words, if you're patrolling, if you're kind of going on this sequence, the path mover manager might go from here to here to there, but then the patrol guy would then go back to the beginning and then do it all over again until somebody tells it to stop. And then the final one is that first, oops, where are we here? The final one is that random one. And you saw an example of that where we basically, the idea is you generate a random destination and you say, go there. And then when you get there, we're going to generate another random destination. So basically you just kind of keep wandering around in kind of a random way, you know, so. All right, so what we're going to look at in just the last few minutes is this path mover manager. So the idea is that it's going to direct a mover to these waypoints. And so it really has, we have two parameters here. One is we're going to have what I call the path, which is we can list it as a 0.2D array. So that's going to be a parameter. So it says, if I'm this path mover manager, I'm going to have these waypoints, and that's where I'm going to send my guide to, period. Now, it turns out that it's also sort of useful to have a Boolean that says I want to start immediately, rather than kind of waiting for somebody to tell me what to do. Its state variables, now thinking of the path, are really kind of two, although they can be a little bit redundant, but in debugging it and just making sure that it's working, one is going to be the next index of my path. So my path is this array of 0.2Ds where I want to send them to. My state variable is going to be the next index, the index of the next point I'm sending it to. And that's going to be initially 0. So that's the first waypoint. So we're dealing with arrays now. So we have the 0-based indexing. And then I'll call it D, which is going to be the next waypoint. And that's initially going to be the waypoint at path 0. So one way to look at the event graph on this, actually just as a, I kind of changed my mind at the last minute because I wanted to change, you know, so I'll have to fix this and thing, but this, yeah, this is more like it. I changed one of the scheduling edges. All right, so for our run, we're actually going to initialize our index to -1 and our next guide and not a point. That actually turns out to make a little bit more sense. And so what it's going to do is that if I start on the run, then I say, go to the next waypoint, and it's going to, its state transition is going to be to increment I. So see, if I starts out at -1, then it goes to 0. So that's the one I want. And my destination is going to be that path at that 1. And then it's going to schedule the move to passing the destination. But when it hears an end move, it's going to say, well, if my index is less than the length -1, again, you have to worry about that, I'm going to schedule the next waypoint. So we're reaching the end here. So we'll pick this up again tomorrow, but just to kind of have this make a little bit of sense. The idea here is that we're going to be listening to and being listened to. So the idea is that, look at this sequence. We're going to, if we say we're going to start on run, we're going to schedule our next waypoint. It's going to say, all right, give me the first guy in the path, pass that as an argument to the move to event. That's going to be heard by our simplest mover, which says move to, which then will kind of go through this sequence. And then at some point, it will schedule an end move event, which will be heard by our simplest path mover manager. And then when he says, is there more left to the path? If so, then I'm going to say, go to the next waypoint, now schedule a move to, then it'll hear the move to again, go through its sequence. Sometime later, it'll have another end move, and that will keep going until you run out of waypoints. So we'll look at that in a little more detail starting tomorrow. Okay. So, and if there's nothing more, I will see you then.